Hello, I'm Dr. Brian Fraser, and in this video I'll be showing how to use Visual Studio's code with the GCC compiler, in fact the G++ compiler, for writing C++ code under Linux. So I've got a Linux, in my case a virtual machine up and running. It's running Ubuntu, and we're going to walk through the steps on getting GCC in, as well as Visual Studio's code. So the first thing I want to do is I want to bring up a terminal where all good Linux happens. And from here, I want to run the apt-get. So I'm going to do sudo to run something as the super user, so super user do. And I'm going to run apt-get update, and then type in my password. So for this to work, I need to be a super user, which is to say have kind of root permissions. Don't do this on some managed computers like in the lab, for example, where you won't have super user access. But if you installed Ubuntu yourself, then you will have access to it. So it's going to go through right now, and it's contacting the web basically, and I've already updated my system, so that's fine. That just basically kind of updates all the packages that it knows about. Next, I want to install all of the things to deal with C++. So I'm going to do sudo apt-get install, and I'm going to list the things I want to install. So I'm going to install build essentials and GDB. And I'm also going to put in GCC, I think I want to put in, or G++. And it's going to list what it's going to install and so forth. I'm going to say, yes, I want to take that. And now it's going to pull down from the web all of these packages that it said it's going to install, of which it's going to take about 50 extra megabytes. While that's running, I'm going to kind of in parallel do something else. So I'm going to launch my file manager. And it automatically defaults to the home folder. So I'm going to create some folders here that I can then work inside of. So I'm going to right click, say new folder, and let's call this one CMPT130 for maybe the course I'm taking. And I'm going to go inside of that, and I'm going to create a new folder. Let's call this one, I don't know, hello test. So what I might do is inside of this CMPT130 folder have a bunch of separate folders for different labs, labs 1, lab 2, lab 3, assignment 1, assignment 2, anything I want. I can create a whole bunch of separate folders in here to help manage my projects. Okay, so we'll come back and use that in just a moment. I've now got GCC installed. I can prove it's installed. I can do G++ -- version, and it will tell me the version of the software that was installed. I should also have GDB -- version. And GDB is the GNU debugger. So I have my C++ compiler, that's G++, and my debugger installed. That's great. Now the next thing I want to do is I want to bring in Visual Studio's code. Now to get that, I need another tool called snap. So sudo apt-get install snap. Snap is a package management system, kind of like apt-get, except kind of has a bit more, I'll say, flexibility for after the fact installs. It's not quite such a managed approach. So now that I have snap, I can do sudo snap, another way of installing things. So install. I'm going to use classic here, which allows it to do kind of many of the things that it wants to do. It gives it more permissions when installing software. And the package name is code for Visual Studio's code. So it'll download it and install Visual Studio's code for me. Okay, so we've got code installed. Let's make sure that it actually is going to work for us. So I'm going to open up Visual Studio's code. And I can do this in a number of ways. Well, it's still installing, I guess, but I could do it in a number of ways. I could launch Visual Studio's code and then tell it to open the folder, this compute 130 folder. But in fact, what I will do is I'll do it all from the command line because, well, a lot of Linux kind of happens from the command line. So I'll demonstrate a little bit of what you can do from the command line. There you go. So if I just type cd enter, it takes me to my home directory. pwd, I'll list kind of the folder I'm in. I'm in /home/Brian. I'm going to go into that compute 130, and I'm going to hit tab here to do tab complete so I don't have to type the whole thing in. And so here's that 130 folder I just created a moment ago. So from here I can launch Visual Studio's code. I can say code and then period. That says load the workspace from the current folder. which is my the folder I'm interested in having everything sit inside of. Incidentally, you could make this folder in GitLab or somehow some managed location so that your code is shared with other systems as appropriate. Okay, so now I launch in, it comes up with the welcome screen. I'll skip that over for the moment. And here we are. We have hello world with nothing in it. So let's create a new file. Let's say a new file here, and let's call this on hello.cpp. And I'm going to type in my standard hello world. So hash include IO stream using namespace std int main loop, and then cout hello world, of course, and line, and return 0. Hello world is my standard program to start with. Now it's going to ask me down here, it says, do you want to install this C++ extension? I do, in fact. I could click install from here, but I'm going to show you how to do it through the IDE just to give you a bit more of a feel for it. On the left-hand side allows me to pick what gets shown here on the bar on the left. We're already at this Explorer pane. If I click it again, it goes away. This is where I'm going to want to normally be. But I'm going to go down here now to extensions. So under extensions, it gives me a list of some popular ones about Python and, well, here it is, C++. C++, the Microsoft IntelliSense and debugger support. So I'm going to click install. It will install and nicely not even require a reboot. It's currently going to go through and update the extensions for me. It allows me to do some insider. I don't need a new version. That's fine. Get rid of that. I'm good. I'm going to go back up here to Explorer. Now, let's see what I also want to do. I want to enable something here under File. I'm going to turn on this auto save, which will automatically save the changes at important points, which is nice because in Linux, I'm going to often be leaving this editor to go do something else. Now, we're going to try to do as much as we can through this integrated development environment, somewhat, but sometimes you move to another place in the file system. We don't want it to not save our changes. So let's run this program. Now, I can go up here to run, and I can say start debugging. It doesn't yet know exactly what to do, though. I have to tell it what compiler to use and what sort of tool chain in order to get this working. So I'm going to check here, GDB is the first one. And then it asks me, oh, well, which of these different sort of variants do you want to support? And I want to take the first one that says G++. Just standard G++. There's a couple of them listed here. Not entirely sure why. I'll just pick the first G++ without a version number. And it builds me this launch.json file. JSON is a file format that just sort of structured data can be stored in. And if you want, you can find all the details about this online. I don't really care about the details here other than it simply is going to work. I'm now going to go back to my hello.cpp. I'm going to go back to run and start debugging, or I'll just come over here and hit F5. It launches the compiler. We see here the compiler has gone through here, and then it launches the debugger and runs my program. And if I look here on the terminal, there it is. Hello world. That's the output of my program that I just ran. Let's prove it is. Cout. Yep, it's the output. This end line gives me a line feed. I'm going to hit F5 again to run. It rebuilds it, we see here. And there it is, my new output. Okay, so we got the program up and running. Now, what's kind of cool about Visual Studio's code is that inside of this whole workspace, if I'm looking at a .cpp file, I can hit F5 and it'll build that file for me, assuming it's a fairly simple project. So I'm going to right click on this, I'm going to copy, and let's create a new folder. I'm going to come back up here and say I want a new folder. And this folder I'm going to call something like, let's say lab1. And I'm going to move it up into the root of this. How do I do that? Oh, I got to do this. Pull it down. Make sure I want to move it. Yes. So I moved it into the root of my project. Then I've got lab1. Nothing's there. So I'm going to paste in hello. And let's rename it. So I'm going to hit F2. And let's call this one goodbye. Goodbye. Over and out. And now I'm looking at a different CPP file. I hit F5. I don't need to tell it to reconfigure the project. It simply loads that information from the launch.json file. And there we have my program ran over and out. All right. So this is going to be a great structure throughout the course because you can have all of your assignments and so forth in one spot down the left-hand side here, nicely organized by like labs and assignments and so forth. Recall though that under Linux and in fact C++ in general, it is case sensitive by identifiers as well as file names. And so make sure that you're typing in consistent file names. Don't capitalize some and lowercase others. Generally, they're going to be lowercase file names. The last thing I want to do is I want to show you some possible things that could go wrong, of which there are many. First one is if you happen to select the launch configuration incorrectly, and this doesn't work, you can simply go over here to the left-hand side, and there should be this VS Code folder. If you open it up and there's this launch.json, you can just delete it. Right-click and then delete. I'm not going to do it here because mine worked. But if you got the wrong one, do that. Try it again, hit F5, and you'll get a chance to select a different option. If it's not working at all, go back to the command line and make sure you type G++. You'll get something. Type GDB, -- version. You'll get something else. Make sure those programs are installed. The next thing is if you get a compile time error. So let me go back in here and I'm going to do the standard one about forgetting to put in a semicolon here at the end. So now when I hit F5, it's going to try and build and then run my program. Well, the build fails, and so that's what it's saying here. It failed to do this build active file task. So what can I do? Well, I could debug anyway, saying I know it didn't build, but debug it anyway. That's foolish because I want to debug the real thing here. I could say I want to say abort or show errors. In fact, it turns out to be quite nice. So if I say show errors, it lists here the errors that it detected, and it thinks, well, here's one. Expected semicolon before the line there. Oh, yes, right. Put the semicolon back in. The file will save. When I run F5, hit F5, it'll run my program. Now we're back up and running. The last thing I want to mention is by running it through the debugger, it's actually pretty powerful if something goes wrong. Now, one of the common things to go wrong is called a seg fault. So we just quickly write one. I'm going to create an int pointer called pheight equals nullputter, and then I can do something like dereference it. Star pheight. Now don't worry if you don't know what this is yet. You'll certainly learn about null pointers before the end of your programming career. But suffice to say, when you do something wrong with memory access, it fails horrifically. And we wanted to do it smartly. So this line of code is not going to work. We're basically saying, hey, here's an address. It happens to be address 0, which we don't have access to ever. And I'm going to look at address 0. Basically, I'm trying to look somewhere I'm not allowed to do that. The operating system is going to stop me with what's called a seg fault, a segmentation fault. And here we see, in fact, that Visual Studio's code, along with GDB, were able to tell me precisely where that fault was. And so it was on here, line 9, it hit a seg fault. I can still see some of my output. Go terminal out. Whatever has happened up to this point, but now it's telling me precisely where in my code it died, which is a very powerful way of quickly debugging your code. Okay, thank you very much for watching.